Hey there, everybody. Welcome to the webinar. We're going to get started here in the next couple of minutes. So please bear with us. Thank you. All right, everyone, we're coming up to the top of the hour here. We're going to give it another minute or two to wait for any last minute attendees. Thanks. Hi, everyone. Welcome. I see a lot of folks filtering in now. Welcome to the webinar. Okay, everybody, let's get this webinar started. So everybody, thank you for taking some time out of your day to join our webinar. It's very nice to have you all here today. My name is Alex Lepore. I'm the Regional Southwest Sales Manager here at Fortress Power. More to come on Fortress Power in the coming slides, and I wanted to thank GoGreenSolar here for co-hosting this webinar with us. GoGreenSolar is a very close partner, of Fortress Power, and today I have Jeff and Todd here to support me on this webinar presentation. So we definitely have a lot of topics here to cover, and I will get started sooner rather than later. So that being said, if you do have questions throughout the webinar, you should see a questions tab on a panel from which you're on, and you can put your questions throughout the webinar into the questions tab. We will either address questions, if they are very good questions, we'll address them immediately, or we will certainly do a 10 to 15-minute Q&A at the end of the presentation to answer any outstanding questions you may have. So that being said, let's get this thing started. It should be around 40 to 45 minutes of presentation time with maybe 10 to 15 minutes of Q&A. So let's get this thing going. So what are we going to talk about today? So first thing we're going to talk about is the history of energy storage. We're then going to talk about some of the different applications that we can use energy storage for, right? Why is this important? How can I use it? And how can I use this on my home, more importantly than not? Right, we're going to then talk about what makes a battery a quality battery, what makes a good battery a truly indeed a good battery, and what are some of those different characteristics. I'm then going to pass it over to Todd to talk about some of the sizing and designing and some of the tips and tricks they have over at GoGreenSolar, which is going to come with tons of good information. And then we are going to have an open Q&A like I mentioned. A lot of you folks are going to get this recording of this webinar along with these webinar slides after the fact. So don't feel like you have to feverishly jot down notes throughout the webinar, as you will get these slides and this recording for your internal review. Or if you're joining us after this webinar was presented, feel welcome to reach out to us with any questions if you were unable to make this live session. So that being said, let's take a look at where energy storage has been and where it's going. So you do have in the mid-50s, specifically in 1954, you have the creation of silicon PV, or photovoltaics. So this was the actual creation of using photovoltaics for silicon in terms of PV modules. And the solar and batteries, or more specifically batteries, began in the mid to late 1970s. The first batteries that came out in the 1970s were traditionally lead acid batteries. And these were common just because of the technology at the time, but also because of the low price, the high functionality, and the availability of those systems. And traditionally it was only for off-grid systems. And in 1996, we have the technology for solar inverters to allow for net metering. So in 1996, you have these traditional off-grid systems which are being used with batteries, and then once net metering gets involved, or where you're able to sell back your solar generation to the grid, that's when we see in the early 2000s a grid-connected energy storage system. So this is where you have the solar system with the battery, and it is connected to the utility. And I'll speak a little bit to some of the applications if you are connected to the utility, or if you're not, for example, in off-grid in the next couple of slides. So since the early 2000s, we've definitely seen a lot of technological advances in many of the applications, certainly in the residential side, all the way up into commercial, utility, and even into the industrial industries. So the whole solar industry has been growing since the mid-50s, and batteries specifically since the 70s, and certainly from lead acid to lithium has been a fairly big change in the last, not even in just the past 5 years, but certainly in the past 10, 15, and 20 years, certainly. In that kind of respect. So what does the next 20 years look like, right? Since we have this grid connection and energy storage is now connected to the grid, the Department of Energy is anticipating that by 2030, that by the end of this decade alone, stationary energy deployments are going to exceed 150 gigawatt hours. So that's a 27% annual growth for grid-related storage applications. So we can see here in this chart that you can find here on this link that the Department of Energy published, that grid-related applications from 2022 to 2030 are going to basically 4 times overgrow in that course of just 8 years. The largest market is going to be North America at a whopping 41.1 gigawatt hours of energy storage deployed. So, looking at the history of batteries from when they were first coming into the market in the 70s to the next 10 years into 2030, we're definitely seeing storage become more of a mainstream market, right? And that's probably because of all the different applications that we can set up, or you can set up your batteries more appropriately with your home or your business. So there's 4 main applications that you can use energy storage for. So the main one is certainly to back up your facility, right? Per the National Electric Code, if you have solar with no batteries and the grid goes out, your solar will stop producing. This is because when your solar is continually producing with no grid, the power has nowhere to go. So the main thing that the batteries have been used for in the past, certainly with lead acids and in the lithium space as well, was backing up your home, right? When the grid goes out, you have solar and a solar battery to power those critical loads in your home when that grid is off. You can also use it in a self-supply application. So this is where in certain states in the US, for example, where they're not allowing you to sell back excess power to the utility because they have certain systems set up in place. So having a battery can basically maximize your PV production, store all that excess solar power for later use, right? Maybe we're going to discharge the battery during the nighttime because you have all this extra power your solar generated during the day. Another common one is offsetting your time of use rates, right? Saving money on your electric bill. I'm based in Southern California, and we have a thing called time of use rates. So this is where from 4 p.m. to 9 p.m. they're charging more than off-peak times, they call it, from let's say 9 a.m. to 4 p.m. So what you can do in this instance, and whether you're in a time of use rate or you're not, is you can charge your battery during those off-peak times, right? When solar is the highest, when solar, the sun's in the sky, and then you can discharge it in the afternoon when you're home and you're running your laundry machine or running your dishwasher, whatever that ends up looking like. So And then certainly you can move it off the grid. So you have a lot of different options to set up your battery with solar. Whether you just want to back up your facility, you want to move completely off the grid, you want to make sure that any excess solar you're taking advantage of because you're not able to sell back, or you want to really cycle your battery every single day to avoid high rate charges during peak times. For example, California, like I said, it's 4 to 9 or 5 to 8. Now you'll see in the bottom left, we have a little section on demand reduction. This is typically for commercial applications, but I have seen it in residential. And this setup is typically where if you get over a certain threshold of usage, let's say it's 10 kW in this instance, the utility company will actually bump you up into the next tier of billing for the remainder of your billing cycle. So typically it is for commercial applications, but I have seen it in residential. So what folks will do here is they'll get a battery and make sure they stay below that threshold. So anything from moving off the grid to being grid tied and maximizing your PV production or offsetting your high rates during peak times, you can use a battery for all these different applications. So for example, in an off-grid application, there is no utility, right? There is no grid that you're connected to. So you're going to power the loads from the PV modules or the battery to the loads in that home. And then you can certainly integrate a generator as a backup to the backup for more resiliency, especially being off the grid, right? You don't have that safety net of the utility as you are relying on, one main power source and one main storage source. So it's always good to have some kind of resiliency there, especially when living off the grid. In this webinar, we talk about a little bit more with sizing, right? And how sizing is so important, especially when living off the grid, because like I said, you don't have any safety net there when you don't have any utility. Now, for example, in a grid export, this is where you have a little bit more backup because you do have the option of the grid. So the main application here would be when the grid does go down, the hybrid inverter and the PV system will continue to operate, powering the loads from the PV or the actual battery bank to these AC loads. So you can certainly move it off the grid where you have no utility, or you have the utility, but just in case the utility goes down, right, because of all the numerous storms that we're seeing, or, I can name 15 different things on why the grid may go down, then you have a backup solution. And during the day, when the grid is connected, the excess PV production, if they allow it in your state, can feed back to the grid, and then they will give you credits based upon what you're feeding back to the grid. This is certainly the most common. I'm originally a Philadelphia native, so what you're typically seeing, especially on the East Coast, is going to be this application here, right? They have the connection to the utility, but they have a solar system with a battery to back up their home if the grid goes down because of that next big storm. The other application that we're seeing is a self-supply application. So if you look at my handy dandy chart here on the right, you'll see you're able to purchase from the grid, right? But you're not able to sell back to the grid. So this is where any excess PV that they're making after the battery is charged, you're not able to net meter. So the PV power is going to charge the battery during the day, right? If the loads are already being powered by the solar, and then it'll discharge the battery at night. So like I mentioned, you are maximizing your full PV production here because you're not able to sell it back for credits from the utility company. So if the battery charge is low, the power can be bought from the grid or be used from the generator. So you still have a little bit more security versus an off-grid project, as you do have a grid as a backup. So you can purchase power from the grid and charge the battery, and then use that battery to power the loads in your home or business. So these are the three main applications that we're seeing. And a time of use would look similar to something like this, to where you're charging the battery during peak times, and then, or during off-peak times, excuse me, and then during those peak times, you're sending the battery power to the load, and you still have that option to purchase or sell back to the grid. But most folks, if it's during a peak time, they want to use that cheap battery power, right? They don't want to spend 50 cents a kW purchasing from the grid during those high times. They just want to make sure that they're using the battery. So a lot of different applications that you can set your home up with, and this is going to depend on what state you're in, what is your ultimate goal for having a solar and energy storage system, along with, what are your goals in the future, right? Because you can only start small and add more on at a later date, depending on many different factors in your own life. So those are the three main applications that we're typically seeing. Now, batteries are still extremely new. So as you do your research, what can you or what should you more correctly expect from a quality battery supplier, right? There's all sorts of hubbub about batteries out there on the space, and a lot of what I'm trying to do is educate folks on what makes a good battery good, right? So not all lithium iron phosphate batteries are the same, and that's the chemistry we use here at Fortress Power, not something like a lithium cobalt battery. So even though we have LFP as this chemistry, not all of them are considered equal, because you'll have different manufacturers will use different chemical combinations, which can determine the battery lifespan along with that quality consistency. So although you have LFP as the umbrella, there are many different factors that affect the lifespan of the battery, how the battery is going to operate, understand their testing conditions, for example, and the quality of that battery. And even furthermore, the same manufacturer, for example, can produce batteries at different levels based on their application or what they're making the batteries for. For example, electric vehicle batteries are different than energy storage, home energy storage, or even telecommunication batteries are all different. So having an LFP battery is not as easy as saying, well, let's LFP. It has these very, kind of, strict kind of characteristics almost. There are a lot of differences between different batteries, even under the LFP umbrella. So one of the things that we pride ourselves on is using the highest safety standard in terms of batteries with our chemistry. So we use a lithium iron phosphate technology or chemistry, and something like the Tesla, for example, uses a nickel manganese cobalt. Now the issue, or not the issue, but the differences between these is that LFP is a lot longer lasting and a lot safer than something like an NMC or nickel manganese cobalt. Now, an NMC, this is the chemistry that Tesla uses in their cars, right? It's a little bit more energy dense. It can give out a little bit more power, which does make sense when you're trying to move a car from point A to point B, right? But for lithium iron phosphate for home energy storage, where you want safety and a lot of life cycles, this is where we're seeing LFP become the gold standard, right, in battery backup, at least for homes and businesses. Now, there's a really cool video on YouTube, and I have the link right down here. So when you get this live, you're welcome to check it out, where they essentially try and put a 10-penny inch nail through the actual cell of an LFP in nickel manganese cobalt battery. Now you'll see with the LFP cell, there is a little bit of smoking throughout the video, but it's a certainly different reaction than something like a nickel manganese cobalt cell where it goes into full-blown thermal runaway. So that is why we choose the LFP cell here at Fortress Power, or the LFP chemistry, here at Fortress Power versus something like an NMC cell or nickel manganese cobalt. There's a ton of great information online about the differences of LFP versus NMC, and I'd recommend, if you jump in and have a few minutes, check out the video, read some articles. LFP is definitely becoming that gold standard, for example. Now, there are four other main things on what makes a quality battery a quality battery. So you have the inside, starting from the inside out, you have the actual cell. You're then going to have the chemistry of that cell. You're then going to have the battery management system, or what is the brain of the battery. And then finally, what is the enclosure of the battery, right? What's around that battery? What's protecting it, let's say. So there are three main cells on the market. There's pouch cells, cylindrical cells, and prismatic cells. And so we use tier 1 automotive grade prismatic cells because of the durability of that cell and the thermal stability and longevity in terms of cycle life. Now, traditionally, a lot of batteries had used a cylindrical cell. It's a little bit more of a low costing option, but certainly you don't have that same longevity based on the math of a cylindrical cell versus a prismatic cell. So we use the prismatic cell because of all these things, and it's going to give you ultimately the maximum bang for your buck when investing, in an energy storage system for your home. I spoke a lot about different kinds of cells, right? I mentioned electric vehicle, I mentioned telecommunication, I mentioned home energy storage, and how a manufacturer can do different kinds of cells for different applications. So an interesting graph here is showing the difference between an automotive cell and a telecommunication cell. So we're assuming that it's from the same manufacturer at a very similar depth of discharge and C rate, and you can see that the automotive cell, which is what we use here at Fortress Power, is going to last almost double the amount versus a telecommunication cell at that same C rate. So it really is super important when considering to invest in energy storage for your home. Know this information, even at a very top level when asking the manufacturer questions, right? What kind of cell do you use? Is it a prismatic cell? What is your chemistry? What kind of cell is it, right? Is it an automotive grade or telecommunications grade? All of this is going to come together for your project and only going to determine how many cycles you're going to get, all things being consistent based on the math. So again, doing your research beforehand, talking with folks like Fortress Power or GoGreen upon different feedback or asking those questions is going to help you get the maximum bang for your buck again when investing in energy storage. The second thing I mentioned is the brain of the battery, that battery management system. So you have two main kinds of battery management systems on the market. So as the brain of the battery, this is what's going to protect the battery from overcharging, low discharging, low temperatures, et cetera, et cetera. So again, we're using the highest quality BMS up to the automotive standard. And the main difference here is this BMS is an actual fuse that will open up to protect the battery cells in response to high input and output power, for example, or a much better response time to the inverter's inrush current. And it comes with that very safe protection with a solid state relay and fuse that can actually open the circuit to protect those battery cells. Other providers in the past 5-10 years, had used a MOSFET-based BMS. So this is a lower quality, more affordable solution, but certainly does not have the same input and output power or that same response time to the inverter inrush current when they start that inverter up, for example. So we're using a digital processor-based BMS seen here on the left, not something like this piece of circuitry seen here on the right. And there are certainly differences and pros to using the digital processor-based BMS. Now, it is a little bit more expensive, but when investing in an energy storage system, you certainly want to use the A+ or A grade materials versus a lower costing option like a MOSFET. So we talked about a few things. We talked about the chemistry of the battery to start, why, what makes LFP better, and that's the safety and long lasting, the cycle life on that. We then talked about the actual cell itself, right? We talked about prismatic cells versus cylindrical. And then we talked about the BMS, and last we're going to talk about what's around the battery, right? What's protecting the battery. So Fortress uses an aluminum enclosure versus something like a plastic or iron enclosure. So aluminum is definitely becoming more popular too, because it is a little bit more resistant to salt water and humidity. It has a much nicer aesthetic, and it does allow for our products, specifically the eflex, to be installed outside. In a plastic and iron enclosure, you do have that possibility for corrosion because of salt water and rusting. Typically, it's only for indoor installations, and it can make for a more time-consuming install, having many smaller batteries in a plastic enclosure, which could require maintenance down the road. So the four key differences or differentiators on what makes a quality battery is certainly the chemistry. Right? The chemistry is 90% of what makes a good battery good. Is it LFP or is it an NMC? And if it is a lead acid, which a lot of folks are kind of moving away from, to lithium, it's because of that long life cycle and that safety. Right? We talked about the cell or the cell type. Right? We have the prismatic cells versus the pouch cells or the cylindrical cells, and there's definitely advantages to using the prismatic cells because of the durability and, again, long-lasting capability. We talked about the battery management system, the brains of the battery, which can respond to an inverter's inrush current and has a higher input and output power for the larger solar systems and larger inverters for large load profiles on homes and businesses that are going to be needed. And then we talked about the enclosure itself. So what's around the battery and why that is so important is because it does have that resistance to salt, corrosion, rust, et cetera, et cetera. So you have four things to think about when choosing a battery for your home or business amidst the plethora of other things in terms of where you're going to be installing it, along with many other criteria. So with that being said, I wanted to introduce Todd onto this call to go over through sizing and some of the tips and tricks GoGreen does when sizing energy storage for homes and businesses. Todd, I'll let you take it away.
All right, thanks, Alex. So I put a few things here on the slide. Basically, when a homeowner calls in, we kind of go over, what their expectations are for the system, whether or not it is full off-grid, occasional off-grid, grid assist scenarios like Alex described. Basically, what we need to know is sort of three main things. We're looking at the peak demand on the inverter, either in watts or amps, the daily energy totals in kilowatt hours, and then the nightly usage in kilowatt hours. Basically, when we have the daily total, that helps us size the solar array, and then from there we take basically a portion of that, approximately 75%, to size the battery bank. Most folks are sizing a battery bank to one cycle, one night worth of power, with the idea that either the sun's going to come up the next day, ideally, or if it's bad weather, you can use a generator. One thing with lithiums you have to keep in mind is that they do have a limit on amperage, and a lot of times it's the charging amps of the inverter that we have to look at. So typically, in a lot of the systems we've designed, we will use about 3 of the eflex units, and that'll cover the charge capability of the inverter. So that'll give a customer about 15 kilowatt hours, of energy storage. For the average home, that's pretty good. A refrigerator may use 2 kilowatt hours a day, and then a lot of the other items that people are trying to back up are typically really intermittent. Things like garage doors, well pumps, and then luckily these days a lot of the associated small stuff, it's really not even worth doing the math on. Things like LED lights, your Wi-Fi, your routers and whatnot, cell phone chargers, they add up to nothing. So Alex, how do we jump to the next slide here? Oh, thanks. So, looks like I already covered pretty much everything that's on here. Basically looking at the current limits on the batteries. I put a little bit of detail there on the charging capabilities of the eFlex as well as the eVault. The eVault is a nice unit for simplicity. That's basically a little bit over 3 of the eFlexes all in one unit. You will want to be in a situation where you have easy access to where that's going, because it's 500 pounds. And so, if it's going down like in a basement or something like that, the eFlex is going to be a better choice. You can carry them in one at a time, whereas the eVault's on wheels and you can roll it around, but in a garage, perfect scenario. I think I mentioned already here, charging current is more likely you're going to run into the limitation on the charging current more so than the loads. Most of your loads that have high current are like a lock rotor amp, for a compressor, a well pump, a motor, things like that. They typically last for milliseconds, so not as critical. And like I said, most of our systems are using either one of the eVaults or 3 of the eFlexes, and that's a really good starting point. For bigger systems, of course, we'll do a thorough load evaluation, figure out how many kilowatt hours we need, and we just go from there. Sky's the limit, really. We can just keep paralleling those using battery combiners. Next slide, please.
Todd, I had a question while we're talking about sizing.
Yeah.
What are some loads that folks should look out for? Like what kind of things, on the critical load panel, things that people want backed up? It might be a fridge, lights. Are there any specific loads you'd recommend folks to watch out for that maybe drain a little bit more at the start or have a high surge? Things that people should just keep a lookout for. Does that make sense?
Yeah, definitely. So a couple of the ones that basically throw a wrench in the plan are resistive loads, heating. If you're in the Midwest, basically those big loads are going to hit you at the worst time, the middle of the night, 3 in the morning. It's pitch black, cold. Nobody's going to want to mess around with a generator. There's no sun, and the heating loads can be, a disaster, 5,000 watts or something. And so propane is a much better option in that scenario. Same thing with cooking, and clothes dryers. They can pull a surprising amount. An electric stove might pull 1,200 watts per burner and 3,000 watts on the oven elements. So again, if it's a permanent off-grid situation, then propane appliances are the way to go, for your clothes dryer and your kitchen stove. If it's an energy backup scenario, then you could get away with it, but you'd want to limit it to just like, 1 burner or 2 burners and just live within the means of your system. And then air conditioning. Air conditioning is one that constantly comes up, because not only is it a big load, it can be 2,000, 3,000, 5,000 watts, depending on the size of the unit. The mini splits have been really nice because One little mini split head can be only 800 watts, and that's really doable. So even in areas of high heat and humidity, you might be able to create at least one room in the house that can actually realistically be air conditioned, and it's doable. But yeah, not only are the air conditioners large loads, they run for hours on end. So they quickly, you'll start doing the math and you'll see 50 kilowatt hours a day. And when you start translating that into the battery bank, it gets real expensive. So
Todd, can you confirm if folks can use their main panel as their critical load panel, or can you confirm that you do indeed need a separate critical load panel when folks are setting up their home to back up, for example?
So really anything's possible, with automated transfer switches, current sensors, anything's possible. But honestly, the best design and the simplest design is to do a critical loads panel, because then you don't have to worry about load shedding. You basically have all the knowledge of exactly what's in that load, what you're supporting. If you're not home and the power goes out and you don't have a fancy automated system with load shedding, you know exactly what your inverter and your batteries are going to be supporting. You can leave all the big loads right in the main panel. And a typical critical load panel is just going to have a circuit for the fridge, some lighting, your internet, a few outlets for charging your phones back up, garage door opener, well pump if you have one, deep freezer, things like that. And that's real achievable. So if you get into a situation where you're trying to back up that main service panel, who knows what's going on? There could be 100 different things there, and your batteries may die, in a half hour.
I recommend the same here, Todd. I only asked that because there is a common question on, well, can I use that main panel interchangeably? But using that critical load panel, I think, just provides so many more advantages. And just correct me if I'm wrong, but you can do solar to start and then add batteries on at a later date. So if somebody wanted to put the solar system on and then add 3 of these eflexes onto their system, that is certainly doable, correct?
Yeah, and that all depends on which inverter platform you choose.
Sure.
Just, not recommending any brands here, brand agnostic, but just saying, for example, you had a Schneider XW or an Outback Radian. Either of those, you have to have batteries. It won't turn on without them. If you have a solar converter, they can grid tie and you can add the batteries later. So that's a really nice feature. So yeah, again, it just depends on which inverter you're going with.
Yeah, and I'm asking a lot of questions. I'll stop. I'm going to move on to the next slide. Sorry.
It's fine.
And I wanted to mention on the Fortress Power side of things, and we're going to jump into some case studies here in a second, folks, but there's a lot of great sizing resources, not only through Fortress Power, but other third-party platforms that you can use when sizing your project, including GoGreen as probably the most valuable resource. So there's different resources on our webpage. We have a YouTube channel. You can certainly go to a online website like Energy Sage or Energy Toolbase. But folks like Todd, and I know Jeff's also here, he's a member of the GoGreen Solar team, they're the experts when it comes to sizing. So, I would recommend them as an initial resource, getting in touch with their team, but there are certainly online resources that you can use, Fortress Power, other websites and platforms to help you. So when you do go to GoGreen, for example, and ask for a quote, you have a general idea of how and why you size, that they can confirm it for you and keep your project moving right in the right direction. So I know, Todd, you're going to go over a case study here in this next slide. Tell us a little bit more about it.
Yeah, sure, definitely. So a lot of times, people call in and exactly like you said, they want to do a grid-tied system, add the batteries later. I think this example here, they went with the batteries right up front, but this would be a situation where you could buy your solar panels, your solar converter, and then, if you like, you could add those batteries down the road. This customer did a very simple system, 3 Fortress batteries, which, like I said, is the minimum. Luckily, even with the minimum size, that's 15 kilowatt hours. In real world, that's a good amount of power. I've lived off grid since about 2008. And for the longest time, I only lived on 8 batteries, 8 L16 batteries. And our battery monitor, we'd use about 60 to 80 amp hours a night, which is 3 to 4 kilowatt hours per cycle. So, 15 kilowatt hours of lithium, I would have almost 3 days of backup there, 2 days for sure. So it's a decent sized battery bank. Yeah, other than that, I would say this system, is typical. A single inverter, small solar array and 3 batteries is a great way to get started, and definitely it's very useful in that regard. Solarc also has a generator input, so basically if you got bad weather or your system's not keeping up, or you do want to run the air conditioner for a while, you can always just turn the generator on. I think we have another case study on the next slide.
Mm-hmm. And I'm going to interrupt you here for a second, just to confirm on the previous slide, you had all these different system capabilities. I think a lot of folks may be wondering, if I start with one system capability and, for example, grid tied backup, can I transition to another system capability even after the battery's installed?
Yeah, that's a great question. So with that inverter in particular, Solarc, and as well as like an Outback Radian or a Schneider XW, those are 3 of the big heavy hitters there in that segment. Any of those can just be reprogrammed, and so you're not replacing equipment. If you end up, say for example, someone says, I want to be off grid, which is in some regards that's necessary. In other regards, people just want it, and so go for it. If you decide 6 months later that it's not really a great idea and your utility power is still on site, you can just change the programming. It's as simple as that. And so you can do grid tie, you could do grid assist, where you're just using them as a charging source if your system's not keeping up, or you can pull the wire out completely and be off grid. So all with the same equipment.
Thank you.
Yeah. On this next slide here, this system was a really fun one. It was basically a family that owns a decent size piece of property. They built 4 homes on it, and the local utility company was just astronomical. I don't remember what the number was, but it was a big number. And the homeowner basically just got frustrated with the power company and said, I'm not doing it. We're just going off grid. I'll show you, kind of thing. And so we worked together, kind of went over the load evaluation, and we did have to get a little tricky there and break it up into a few systems for reasons I won't mention. But it turned into a really large system. I think we had 60 solar panels per array, 3 of the 12K Solarcs, and then 4 eVolts per inverter cluster. So definitely one of the largest systems I've ever worked with, and I was in California. So really, really fun project, and it's fully off grid. So, and again, like I mentioned, if they decide that it's not working out as planned for any reason, or they want to take advantage of a net metering situation, the utility is right there. And who knows, maybe the utility would be more willing to work with them now that they see what they've done there.
Todd, I was noting there's a lot of DIY resources, and for folks that have jumped on here and they want to get some preliminary information, they go to your website, right? They start kind of poking around. Maybe they did their own research. What would you recommend for them to come ready to the meeting with you with after, let's say, they submit a form to your website? Do you have any input there? Obviously, there's a ton of resources you guys offer at GoGreen: consultation, design work, permitting, install guides for our DIY customers out there, technical support. It's a lot to take in. What would be a good flow for folks to at least start working with you directly? Go through the website. I know we'll have some contact information on the next couple of slides. What does that look like in respect to GoGreen?
Yeah, sure. So I've been designing and selling battery-based systems for about 12 years now, and I've found that sometimes people will get a little bit too ahead of themselves, and so I honestly prefer just to hop on the phone, have a quick discussion, and I've been complimented many times where I can help save people a ton of time, where we basically just cut to the chase. Within 3 minutes, 3 to 5 minutes, we can start having, a nice educated conversation, and I can start directing them. I like to use the website as a tool. We start looking at systems together, and I just go over capabilities, energy usage, inverter sizes, battery bank, budget's a big one. A lot of times we're designing to a budget, which is, it's definitely realistic. We can look at that, and then I can just kind of say, well, for a system this size, you could expect to run these types of items. This is your max wattage. So say, for example, you can afford a system that has 1 inverter, but maybe you have all the loads in the home maybe add up to 15,000 watts, right? Doesn't mean you need to run them all at the same time. So maybe when the well pump's on and the fridge is running, you're not making toast. Just wait a little bit. Now you make your toast. So you can definitely learn to live within the means. You know, my entire house, I have about a 2,000 square foot house with four people in it. And for the longest time, we've lived off one 4,400 watt inverter. And it's, you know,
Wow.
it works just fine. So.
This is all really good feedback. And folks, I want to, the next slide is going to be an actual installation. And this, I think in these cases, it's Solarc with the eVaults and maybe the eflexes, but this is how this would look in or near your home in the next 3 slides. So you'll see in this situation, this was a residential home, I believe up in the San Diego area, where they have 3 of the Solarcs and 6 of the eVault Maxes. Now this could be this looks like, at least from my point of view, this looks like a whole home backup sort of deal. So this is where someone's backing up their home for, you know, many hours in the event of a grid outage, or in California, there's a PSPS, a public safety power shutoff because of the high winds and wildfires. So this would be synonymous with a very large system where they're backing up. You know, they may have a meat freezer, or they may have some other loads in there that are pretty substantial based upon the amount of batteries that they're getting. And something like this, and this is a special setup where it's a Solarc with 2 eflexes set up in a certain way. But this is more, you know, I think congruent with how a typical project would look for my residential folks out there, backing up some of those critical loads, right? Todd mentioned, you know, your first few critical loads are like that refrigerator, lights, your modem, you know, PlayStation 5, I don't know, whatever that looks like for you. So this would be, I think, more congruent to what your system may look like. This would be, you know, the other side of the bell curve, you know, on the more larger systems. But this is how you could set that up. So we have the one big battery at Fortress and a more smaller battery, which can be installed on the wall in the event you can't fit something like our mini fridge looking battery in your garage, for example, like it is set up here in this case. And then we have something where this is like middle of the road. So this is, like Todd said, this is your standard system where it's 3 of the eflexes in a custom rack that they built with the same Solarc inverter here in this case. And this would be basically the backup for those critical loads in the event of an outage. So this is how your system would look. Now, like I said, you can do indoor, you can do outdoor. Just consult with GoGreen or Fortress Power on what your home looks like, right? What room do you have? Where can we make room? What does that look like working with other folks to make sure that you're kind of crossing your T's and dotting your I's. So this is how it's going to look. And I wanted to mention this because a lot of folks have, well, the case studies are great, but what's it going to look like in my home? And this is exactly how it's going to look. You can tell it's a very clean look. It's very, you know, futuristic almost. Definitely something I'd be bragging about to my neighbors with this first system here if I had something like that. Fortunately, my apartment complex doesn't let me do that. So kind of a bummer, but what are you going to do? So that is all I believe Todd and I had here for you today as we come up into, I believe, the 40-minute mark, which is great timing. And you'll see on the left-hand side, you'll have Todd's email number and the website. So I recommend emailing Todd with any questions you might have, checking out their website if you're putting together a new system. And then you'll have on the right-hand side the information for us here at Fortress Power, including our sales email, technical support, and then for our warranties. So definitely reach out. Feel welcome to use GoGreen and Fortress as your confidants when setting up your solar system, because we're certainly glad and here to help. So with that said, I'm going to pop open the old questions tab and we'll go through some of these questions, see if we can address anything here and now. Okay. Okay, let's see. So the first one, Robert L says, has a question about enrollment to virtual power plants. This is a really good question. So, you know, virtual power plants are typically used in like neighborhoods or things like that. And I've only worked on 1 or 2 of them, quite honestly. Todd, do you have any familiar with VPPs at all? How they're typically set up? I know they're used with, you know, like something like a Solarc and an eVault Max, but they kind of interchangeably move power around. Is that right, based on your understanding?
You know, I'm not familiar with the term.
Okay. Yeah, my understanding is it's basically where you have many, like a big deployment of batteries and solar, and then you would use that virtual power plant to pass energy around, and the utility is somewhat involved. Robert, I can try and find more information for you. I do know it's something I've worked on with, not extensively, quite honestly, but I'd work with you on it and see if we can find some more information.
I would add, If it's a concept of just a shared off-grid system between multiple homes, it usually doesn't work out well. In my experience, I've almost always advised to do separate systems for each home. Otherwise, you end up with one person that kills the system and 3 people that are mad at them.
That's a good point. I had a good question from Eric Zeiss. What are the underlying attributes that determine the longevity of a cylindrical versus pouch versus prismatic cell? I would have thought that the usage or battery management would be the primary determinant of life. Eric, that's a fantastic question. And although the battery management is definitely number 2, some of the attributes include how the cell is built, right? How is the cell actually built in its format, right? Even if it's phosphate, you'll see the prismatic cell is more of a rectangular shape versus a cylindrical. It's a cylindrical shape. So the first thing in terms of the attribute, the actual format of that, the form factor, which makes it for more efficiency with a prismatic versus a cylindrical cell. The second thing I think is just in terms of like the space, right? In terms of prismatic cell, you have rectangles that fit really nice and neat and parallel nicely versus cylindrical cell, which takes up more space. So the prismatic cell is just, I think, when you look at the form factor of it, along with the, how it fits into these battery enclosures, it's a little bit more efficient, and you still have that lithium iron phosphate. So it's still that very safe, long-lasting chemistry. Let's see, we have a lot of questions. Azalea, please recap the min-max number of eflexes and batteries connected in parallel or series. Todd, I'll let you take this one.
Gotcha. So yeah, all of these are going to connect in parallel. As far as a maximum, really you're kind of limited by the infrastructure. The BMS would probably have a maximum listed somewhere. As far as, do you know that, Alex, offhand?
I don't know, unfortunately.
Yeah, it's much higher than anything I've ever run into. Usually you're going to hit some high amperage ratings pretty quick, for residential especially. Commercial, probably a different story. But at that point, you're going to have, buses that are custom made. Midnight makes, some battery combiners that are 1,000 amp rated. So far we haven't run into any walls with that at all. So I would say I haven't run into a maximum situation really. But minimum, I can address the minimum real fast. Basically, the spec sheet is just going to show you the max discharge and max charge rate per battery. And once you parallel those, they add up. So for example, just, if it was 50 and you had 3 of them, now you can charge at 150 amps. Most of the time, your system, when you look at your wattage of the array and then divide by the nominal DC voltage or the charge rate of the inverter, you're not going to run into any limitations there with 3 or more in most scenarios, unless you have a whole pile of inverters, but it's pretty easy to figure out.
There are a few questions regarding the compatibility on Fortress with SolarEdge or Enphase. And David, Robert, the thing is we're a 48-volt battery. So the SolarEdge would be technically a high voltage system. So there is a way that you can put a kit together with the SolarEdge or Enphase, Robert. But what we'll need to do for existing systems like that, or if you want to use that, we will need to look at some string inverter like, Todd mentioned the Schneider or Outback or Solarc to use that. Now, there is a way that if you have an existing SolarEdge system that you can AC couple it or add on the string inverter multi-mode 48-volt system to then connect our battery. So that is certainly a possibility, but there is no direct connection between the SolarEdge or Enphase with ours because it's 48-volt battery nominal voltage. There's the high voltage battery. I had another question from Myron Diener. Hi, Myron. Thanks for jumping on here. Generally within city codes, is a DIY homeowner allowed to install their own batteries? Generally, Myron, you are allowed, being in LA County, probably not just in this area where I'm at, but the US, I think generally city codes are open. I think just talk to your municipality, right? Talk to them, get the proper permits, stay in communication with them. Most of the time, I think you'll be fine when working with your municipality if you're doing a DIY project, but just do your due diligence would be my feedback there. And to answer your second question, Myron, we have I think it's a 95 or 96% round trip efficiency with these batteries. So from solar to inverter to battery, battery to inverter to the load is like 95% or so. So it's a very high efficiency round trip. to get back to your AC loads. You're not going to be losing a lot of efficiency there. Eric, you're exactly right. This question speaks to upcoming NEC codes to appear to be pushing lithium batteries outside in the Northeast. What would you recommend? Cold temperatures are not nice to batteries, guys. Not nice at all. So in colder climates, I'm recommending some kind of heating element, right? This could be heat tape like they use in plumbing applications, or it could be something as simple as trickle charging a space heater in the Northeast. In Vermont and New Hampshire, I remember doing projects where they had heat tape on the sides of the batteries because it was a battery outside in the cold in like an outhouse or some other kind of outdoor fashion shed, and they use that heat tape to keep the battery in our recommended temperature ranges, which is 32 degrees Fahrenheit to 113 degrees Fahrenheit. So there are different heating applications, Eric, that you can use, especially in the Northeast climate. Being from Philadelphia, I know all too well about winter time in the Northeast, and those heating applications can definitely keep us in that range. Chuck had a question. Does Fortress Power require one solar arc per eVault? Does it still apply? Chuck, this is the case. It will be a minimum of one solar arc 12 to one eVault max 18.5. And then John had a good question for you, Todd. Can you comment on the use of heat pumps for home heating with the solar panel and battery configuration?
Yeah, basically, the HVAC world is a little hard to break through sometimes because they like to use BTUs, and so a lot of folks, what I recommend is getting with your HVAC installer and putting a multimeter on the exact unit you have. And once you know the amps it's pulling and the volts it's running at, we multiply those together. That's how you get watts. The only formula I've ever needed to know in 12 years of designing energy storage is amps times volts equals watts, and I just gave out my secret. But basically, yeah, once you know the actual load, and then you can, if especially if it's your own home, you can get an idea for how often that's running. Is it 1 hour a day, or is it 20 minutes an hour, 24 hours a day? Then we can get an idea of worst case scenario on that heat pump, and once we have watts, it's easy. Anytime it's in HVAC units, then it's a mystery. So we got to convert that to watts. But yeah, it's definitely doable.
Well said. Charles, what is the depth of discharge a battery will typically design to? Most batteries will do 80% DOD, and that will give them the full 10-year warranty based on the cycle life. So for example, ours is a 10-year warranty, 8,000 cycles at an 80% depth of discharge. Now, if you're not living off the grid, sorry, if you're using a battery for emergency power and you're not cycling it all that much, that would be an instance maybe use 90% depth of discharge, right? You're going to get the maximum amount that you can to power those loads in the event of an outage. But for constant cycling, for my off-grid folks out there, we recommend the 80% depth of discharge. Ed, we will have these slides later for reference. Dennis Huber asked a very good question. When do you think NEM 3 will start in California, and how this affect future solar installations? Wow, Dennis, that is a fairly big topic. Oh man, I was at the NEM 3.0 rally that was held in Los Angeles a couple of weeks ago, and I know they did delay the decision making on NEM 3.0. When do I think it's going to start? No idea. It could, if they motion for another delay, that could push it back. I know there's a lot of feedback coming from folks in the industry and even outside the industry, really telling the PG&E, for example, that this is completely ridiculous. If it does go through, to answer your second question, basically it's going to make it, for future solar installations, it's going to make it much harder to pay back that solar installation in comparison to years past. So this is actually going to, I think, help battery installations, because if you're buying it for 2 cents a watt and they're only going to give you 1 cent a watt for net metering it back, having a battery can maximize all that extra that you're getting and just send it right to your AC load, right? You're not going to send it back and have them give you, a few pennies for what you're generating. So I think it's going to really push solar installations to be true multi-mode or battery installs versus just the traditional grid tied systems. It's a great question, fantastic question. Mark McDaniel asked a good question for you, Todd. Does the watt calculation go for pool heater as well?
Yeah, any electrical load. So amps times volts equals watts. And one of the things that a lot of people get tripped up on is when they see an amperage rating that's based on a low DC voltage. And so, it's just as simple as taking, for example, at 12 volts, right? If you see 60 amps or 100 amps at 12 volts, it's 1200 watts. It's the same as 10 amps at 120 volts. And so sometimes there's a little bit of learning curve there. But once we put it in watts, everything's equal. So it doesn't really matter, what type of load it is. Once it's watts, it's just the watts times the runtime, and then we have the daily needs of that load.
Robert had a good point. He said permits save lives. They sure do, Robert. And Todd, I had a good question from Douglas Clark, who I believe you should connect with directly. He wanted to know if you could outline the GoGreen service flowchart from the initial contact to the install, and learn a bit more about, how does GoGreen connect, if you guys connect the solar installers, and I think he wants to learn a little bit more about your process there. So Douglas Clark, if you can please send over an email to Todd. I have his email down here. I think he can help you out with some of the flow and working with you guys in that kind of respect.
Yep, definitely.
Yep, and last question here, everybody, as we come up into our hour mark. It's a good one. Gary Gonzalez asking, do you have a cheat sheet specifying the minimum number of battery types? If you check out our website, Gary. On our website, go to support. When you drop down the support menu, you're going to see minimum inverter sizing guidance. You can use that as a quick cheat sheet for your sizing, at least as a minimum, and then you can reconcile that with folks like Todd over at GoGreen to see, okay, minimum we're using this, but my project may be calling for 4 more batteries, for example. So our website, for everybody still on the call, has a ton of good information for sizing, designing, upcoming webinars, minimum sizing guidances, installation manuals, and the whole 9, at least with Fortress. And GoGreen has a ton of great information on sizing, designing, plan sets on their website as well. And we have both the websites down here at the bottom in that kind of respect, so you can check it out. So with that said, I'm going to end the webinar here and now. Please direct any other questions directly to Todd or myself. You can shoot them over right over to sales@fortresspower.com. And again, thank you guys for joining the webinar. Todd, thank you for your time here and co-hosting this webinar with us. I had a great time and definitely looking forward to the next one.
Yeah, thanks for having me.
Right on. Everybody have a great rest of your day. Thanks again.
All right. Thanks, everyone.